continuing on to example 2 on how to do the p-value approach for a hypothesis test. So this example reads, a 2003 study conducted by the Environmental Protection Agency, the EPA, found that 6.25% of airplanes tested had confirmed coliform bacteria from the drinking water in the bathrooms and kitchens from a sample of 320 airplanes. As a benchmark comparison, 3.5% of the U.S. population have coliform bacteria-infected drinking water. Does this present significant evidence that the drinking water on airplanes is more contaminated than drinking water in general? Use a level of significance of 0.05. So I'm going to start this problem the same way I started the last one. I'm going to underline anything that I found from the problem, the statements, that might be needed to run this hypothesis test. So the study found that 6.5% of airplanes tested had confirmed coliform. They found that from a sample of 320 airplanes. The benchmark comparison is 3.5% for the U.S. population. Is this significant evidence? That's my key that this is a hypothesis test. So remember, we're looking for evidence to reject. So significant evidence is what tells me that this is a hypothesis test. Is more contaminated than drinking water in general. And a level of significance of 0.05. So I have 6.25%. Just so you know, 2003 is just telling me when the study was. I don't need to underline that because it's not actually a number that I need for this problem. 320, 3.5%, and 0.05. These are the 4 numbers that I underlined. Again, I'm going to start with the ones that I can identify more easily and work my way backwards. So level of significance is always alpha. They took a sample of 320 airplanes. That's going to be N. So then I have 2 percentages to work out. So 6.25% of airplanes tested had confirmed chloroform bacteria from the drinking water in the bathrooms and kitchens from a sample of 320 airplanes. So this 6.25% is connected to the sample of 320 airplanes. So that makes it P hat. It is the percent of infected or of bacteria-ridden water from the 320 sampled airplanes. Let's make sure that that matches so that 3.5% would be the population proportion. As a benchmark comparison, 3.5% of the U.S. population have chloroform bacteria-infected drinking water. That works. So we have population proportion. And again, as a benchmark comparison, so as a comparison, as something to compare that to, as a, this is where it should be, I'm using this to kind of look to see, like, is it different from where it should be? So that's going to be my population proportion. So the first thing I'm going to do is I'm going to write out my null and my alternative. So my null is going to be that the population proportion of drinking water that has coliform bacteria should be equal to 3.5%. Looking at this guy here, P equals 3.5%. That's what your null should be. 0.035. And then HA, we want to know if airplane water is more contaminated than that. So P is greater than 0.035. So now in this case, we have a right-tailed test. So I'm going to go ahead, I'm going to do step 2 and 3 by hand, just like I did with the first example, and then I'll go ahead and do it in Excel as well to check and make sure. So step 2 is finding your test statistic. And again, that z-score equation is p hat minus p over the square root of p times 1 minus p over n. So now this time we were given p. I just want to go ahead, or sorry, we were given p hat. I'm just going to go ahead and write that out as a decimal instead of a percentage. You could write it out as a decimal when you're writing down all of the numbers from the problem as well, so you don't have to remember to do it later. So 0.0625 minus 0.035 is what p is equal to, divided by the square root of 0.035 times 1 minus 0.035 over 320. Again, I recommend doing the top part minus doing the top piece first. So that's 0.0275 over, and the bottom turns out to be a long number. We want to keep all of those decimals. There we go. Those are all the decimals. And then I'm going to do that division. And I get a z-score of 2.6768. And let's put a little note back up here. I apologize. This is if you're doing this by hand. And then step 3, once you have that test statistic telling you how far away from the mean you are in terms of standard deviation, you find the p-value by hand. And again, p-value stands for probability, so we know our answer for step 3 has to be between 0 and 1. The p in p-value stands for probability. So we have our z-score. If it's helpful for you to continue drawing the curves and doing the shading, please do so. If you do not feel you need to continue drawing the curves and you can go from the z-score straight into Excel, you can also do that. So 2.76, that's where my z-score is. I'm going to look at my alternative. To determine where I would shade on my curve, because I do still like to draw the curves. And my alternative is greater than. So that would be everything here. Because it's greater than, when I go into Excel, I have to do 1 minus norm.s.dist. 2.6768, comma, true. And what do we get? Again, I have this on my computer, not in front of me, because all I have is the inference worksheet in front of me. And I got 0.003 7 for the p-value. So the test statistic by hand is 2.6768. The p-value by hand, again, you can draw the curve if you like. Greater than, because that's what we have in the alternative, is p is greater than 0.05. It's a right-tailed test, so it's greater than. So when we go to Excel, we have to do the 1 minus norm.s.dist. If we want to do this in Excel, I'm going to do this in green. I'm going to slide this over so we can see more of the Excel screen. Not a whole lot that we got to do. My keyboard keeps turning off. There we go. Okay. So HOP equals 0.035. Why isn't it typing? Hang on. I'm sorry. Don't do this to me. Okay. Maybe I can get this to work here. Okay. 0.035. 0.035. Our N is 320. And our X, oh, we don't know what our X is. We need to go find that. So for this one in Excel, we were given p hat, we were not given X. So we need to find X in order to use the Excel sheet. So to find X, remember p hat is X over N. So p hat is 0.0625, and that's X over 320. So if you know p hat and you need to find X so that you can use Excel, multiply your p hat by your N. P hat times N equals X. Using just a little bit of algebra. Okay, so the 320s cancel on each side using the algebra. I have 320 times 0.0625. So X equals 20. So that's what we're going to plug in over here. Scroll this down. There we go. And our alpha, again, we don't really need it in here. That was more for some of the other classes. Oh, and then we do want to make sure that we change this to be the correct symbol. So right now this is doing a left-tailed test. We don't want that. We want a right-tailed test. So I get Z of 2.6768 and a p-value of 0.0037. As long as you change this symbol from less than to greater than, you don't have to do anything to the p-value. It will calculate the correct p-value for you. So long as you put the correct symbol from this guy, the drag down. Make sure you change that to greater than. If it's still in the less than, then it won't be correct. But if this guy you change from less than to greater than, then you'll get the correct p-value. Excel knows what it's doing. So I get the same answers when I do this in Excel. So now I have, whoopsies. Oh man, okay. I have my test statistic, my p-value. All I need to do is look and see if my p-value is small enough to reject. So that's my conclusion and my interpretation. So that interpretation, again, is putting it into a sentence with context. It has meaning. We don't use the word it. So remember, for the conclusion, we want to know, is our p-value too small to be plausible? Is the p-value less than the alpha? The alpha tells us what a small number would be. Tells us what too small is. Even though this is greater than up here, that doesn't matter anymore. We already took care of that. We took care of that when we calculated the probability. What I want to know is the p-value too small to be plausible? So is 0.0037 less than my alpha, which was 0.05? Yes. My p is low, so I'm going to reject HO. I'm going to reject the null hypothesis. So for the conclusion, is the probability of your results too small? Our probability is too small. The percent of planes with contaminated water is so much higher than the rest of the population that, yeah, airplane water is more contaminated than the rest of the population. Yeah, 6.25% is too many planes with contaminated water. So the interpretation, we reject the null hypothesis and conclude that there is enough evidence. You can use enough evidence or sufficient evidence. I'm not picky about that. I have a hard time spelling the word sufficient. So I tend to use enough. There is enough evidence to conclude, whoopsies, that got a little bit crazy. That the proportion of airplanes with, and what specifically, what were we looking at? Coliform bacteria in the drinking water is more than the, and again, I'm going to come back up and I'm going to look, is more than more contaminated than drinking water in general, but I want to reference the percent. So is more than the 3.5% of the U.S. population. With coliform bacteria. You could also put a summary here. So yes, plain water is more contaminated. Woo! Then drinking water. In general. Bring your own water on a plane. That's what this is telling us. This also told us how to do a hypothesis test for a right-tailed test with proportions. Scroll back up to the top. There.